analysis of variance or Anova illustration. Set up analysis of variance table for the following paragraph. Production of data for 3 varieties of weight is grown on the 4 plots and state if the variety difference are be significant. Okay, how to solve F coefficient or variance of ratio by using Excel and SPSS Anova. Variety and output. Variety A, B, C, and the output for A is this value, B for okay, C are given. Now, how can we solve this problem? To solve this problem, we can use 2 types of software for this video. One, Excel, the other SPSS. Okay. The number of output is 4. For A, B, C are the same. So let us do first by Excel and second by SPSS. Now first let us do it by Excel. Let me open the Excel. This is a Microsoft Excel. Okay, and the data what I have shown here is this one, this value A, output B, and here is this value, variety ABC, and the output. Now to solve this problem, the first thing what I'm going to do is that I'll go to data in the Excel, and in the data menu I do have analysis, data analysis, and in the data analysis you'll go to Anova, a single factor. Okay, then you'll enter the value. Okay, from this one to this one will be given. Again I'll go grouping by column. No, it's grouping by rows here, so I'll click rows and I'll go back and check my selection here. Okay, it's okay. Now grouped by rows, then output here, I'll click output. Let me select my output area. Say let me select around this one. Let me select this area for this purpose. Again the remaining is Anova single factors. Input range is given here. I've done like this one. Again, and grouped by row. Okay, it's checked, and output option checked. Output option is given here. Okay, now click OK. Anova single factor input range contain non-numerical data. Okay, yes. Now what I did is that to be it is okay, I did one thing. Okay, Anova single, I checked this value. Okay, select this value and again group by row and check the labels in the first column. Now tell this one, the first column and this one is labeled. That means it will ignore as if it were not the numerical. That means it is string, so it's possible to do that. So let us check the result here. let me cancel this one, cancel. Okay, here if you check the result here, okay, within a second it is grouped, the group ABC, and count number 1 2 3 4 4 4 4. The summation of this number, for example, if you check this number 6 7, okay, is 30 30 16 16 24, okay, like this one, and average and variance of each value is given, directly calculated. Then the other is the Anova. The Anova between here, between group, in the group, okay, between group and within the group, okay, here is 8 and 24, degree of freedom 2 9 11, the variance of 4 and 2.6, and F ratio is 1.5. okay, when you compare it with the table value 4.3, it is less than the table value, so it is insignificant. The effect will be insignificant. Okay, in the same manner we can calculate solve by using, okay, SPSS. okay, we have got like this one. We can use our software like by Excel. In the same manner we can do by SPSS. okay, let us click data view here first and go to the Excel. In the Excel we have given this value. If you use this value, okay, it doesn't accept. Let me show you. If I copy this one, copy and paste here, copying is not active here. Let me again copy. Yeah. Copy again, copy. Yeah, if you go to analysis, then compare the mean and one-way Anova or a single Anova. Okay, we don't have the factor. Okay, it doesn't call the string, it only calls the number. So here if you go to the variable, here is string and numeric. When you use analysis, it only calls the string, it doesn't call the it calls numeric, not string. Okay, so what should I do to solve this problem? Instead of using numbers, symbols like A, B, B, C, I prefer to use numbers instead of like this one. Okay, instead of A, number 1, number 2, number 3. So let me copy this one and you will see the difference. Okay, copy, and not to confuse, let me open the new data. Okay, yeah, let me click here. Okay, now let me show you analysis. Go to compare the mean, compare means, 1 Anova. Now instead of 2, now both variable 1 and variable 2 are opened. Okay, so I can, 1 means factor here, 2 means dependent list. So if I click here, the Anova value will be displayed here. Okay, it's 1.5. okay, the degree of freedom is 11, and the sum of the square SS is 32 8 24, and degree of freedom is 11. The mean square is 4 and 2.6. Okay, the F ratio is 1.5. Here in the Excel also, it is 1.5. So both softwares give us the same results. Okay, the interpretation lays that this value 1.5 is less than 4.3 for 11 degree of freedom. So we have 2 and 9. Okay, by comparing the degree of freedom and the F value, we can conclude that it is insignificant. Thank you for watching this video. If you have any question and doubts, write down in the comment box. I'll try to give you the possible answer. Bye bye.